Okay guys, we're going to go ahead and go through this Module 2 test review. There is a non-calculator section and then there is also a calculator section. So for the non-calculator section, really you want to make sure that you are studying your perfect squares and your cube roots, making sure that you have those memorized so that you can use those, have those in your brain for the test. So let's go ahead and look at number 1. Number 1, you're solving equations. So we want to solve the equation, we have to do the inverse operation. The inverse of squaring is square root. So we're going to do the square root of both sides. Square root of x squared gives me x. Square root of 81 is 9. I have to remember with square root equations though, that my answer could be a positive 9. It could also be a negative 9. So it has to be plus or minus 9. Because 9 times 9 is 81. Negative 9 times negative 9 is also 81. So both of those are answers. B, inverse operation, square root of both sides. X equals plus or minus 12. C, cube root. We've got to do the cube root is the inverse of cubing. So we do the cube root of both sides. So cube root of x cubed is x. Cube root of 8 is 2, because 2 times 2 times 2 equals 8. D, got to do the inverse, which is cube root. We do the cube root. X equals cube root of 343 is 7. E, squaring, got to do the inverse, which is square root. Square root. That's going to give us x equals, we do the square root of the top, square root of 1 is 1. Square root of 25 is 5, and this is a squaring equation. So remember that we have to do plus and minus, that both of those are answers. Then we do F, we've got to do the cube root of x cubed, and we have to do the cube root of the other side. X equals cube root of 27 is 3. Cube root of 125 is 5. So x equals 3/5. Number 2, okay, looking at our word problem. Noah's arranging Mr. Rudig's desk as an after-school punishment. There are 36 desks, and the desks need to be arranged in a square. How many rows will there be, and how many desks will be in each row? I know that a square means that both sides have to be the same. I know that the total number is 36. So we're going to work with this like area, okay? S squared, okay? S squared, our area, is 36 equals S squared. We're going to do the inverse operation, square root, okay? S equals 36. I said that wrong. S equals square root of 36 is going to be 6. Now, normally with a square root equation, we end up with a plus or a minus. In this case, a negative does not make sense because you cannot have negative 6, so it has to be a positive 6 for the number of desks in each row. Okay, so let's go ahead and look at number 3. Number 3, Miss St. John is renting a square prism, okay, that shaped storage unit that is 1,000 cubic feet. So prism, that's letting us know that it is a cube. What are the dimensions of the storage unit? Okay, volume equals S cubed. So volume is 1,000. Okay, equals S cubed. We want to do the inverse, which means cube root. Cube root. Cube root of 1,000 gives me 10 equals S. So each side of the storage room or a storage unit is 10 feet. Number 4, without a calculator, identify between which two whole numbers the following numbers belong. Circle the one that it is closest to. So we're estimating without a calculator. So square root of 12, I know that that square root of 16 equals 4, and I know that the square root of 9 equals 3. Square root of 12 would fall right in between those. So that means square root of 12 is right between 3 and 4. And square root of 12, it is 3 away from 9. It is 4 away from 16. That means it is slightly closer to the 3. Going to B. We want to know what numbers the square root of 120 comes in between. So, thinking about what we know about square root of 120, I know that the square root of 100 equals 10. I know that the square root of 121 equals 11. That means that it comes right between 10 and 11. It's almost up to the 121, so that means it is closest to 11. Next one, we want to know square root of 156. So, thinking about what we know, okay, I know that the square root of 144 equals 12. I also know that the square root of 169 equals 13. So that is right in between there. So I know that it is between 12 and 13. So thinking about which one that it is closest to. Okay? It is, if I do 169 minus 156, okay, it's 13 away. If I do 156 minus 144, it's 12 away. So it is slightly closer to the 12. Okay, square root of 144, or I'm sorry, square root of 45. Thinking about where it falls. I know that the square root of 36 is 6. Square root of 49 is 7. So that means that it falls between 6 and 7. It is only 4 away from that square root of 49, so that it is closer to 7. Okay? Now, the next part, we're estimating, we're still not using our calculator to be able to figure this out, but we're going to use the same things, the same skills we were looking at in number 4 to help us with our estimating. So, A, square root of 17. I know that the square root of 17, okay, if I think about it, I know that it is between 4 and 5 because I know square root of 16 equals 4.
Good morning, Untitled Middle School.
So we know that square root of 25 equals 5, so square root of 17 comes right in the middle. Now this time we're trying to figure out what the decimal would be to the 10th place. So when I think about square root of 17, it's really close to the 4. So I know my whole number is going to be 4. And it's just slightly bigger, so I'm going to estimate that it is about 4.1. Now looking at B, square root of 60. I know the square root of 49 equals 7, and I know that the square root of 64 equals 8. So 60 comes right in between there, and it's actually closer to the 8. So I know it's between 7 and 8. It's actually quite a bit closer to the 8. So when I estimate that, it's going to be 7, and I'm going to say it's about 3/4 of the way. So I'm going to go with 7.7. C, square root of 30. I know that the square root of 25 equals 5. Square root of 36 equals 6. So when I think about where that is coming, in between there, it is almost right in the middle. So I'm going to go with 5.5. All right, so number 6, which real numbers are rational numbers? I know that rational numbers, they can be converted to a fraction. I can also tell really quickly if it's a decimal that is repeating or if it is terminating, that those can be turned into a fraction, which makes them a rational number. So which real numbers are rational numbers? Negative 18, it's a rational number. 0 is a rational number. C, it is a non-terminating, non-repeating decimal. So it is not a rational number. And then D, square root of 16 equals 4. Therefore, it is rational. Number 7, which real numbers are rational numbers? With A, 2.2225, it's a terminating decimal. It's rational. B, square root of 20 over square root of 5. If I simplify this, let's look at it. If I go 20 divided by 5, that's going to end up being square root of 4. Square root of 5 divided by 5, that's going to be square root of 1. That ends up equaling square root of 4 is 2 over 1 equals 2. So it's kind of a tricky one, but it's rational. C, 1.45445, it is not repeating, it is never ending, it is not rational. D, let's see what happens when we simplify. 9 pi divided by 3 gives me 3 pi over 1. It is not rational. 8, we're kind of flipping the question. Which real numbers are irrational numbers? So, looking at A, it is going on and not repeating. It is irrational. B, pi, 5 pi, irrational. C, square root of 64 is 8 over 9. It's a fraction. It is rational, not irrational. D, square root of 2 over 3. Okay, cannot be simplified. It ends up being irrational. Number 9, which statements are true? The number negative 2/3 is irrational. That is not true because it is a fraction, so it is rational. B, the number 50.2 is irrational. It is a terminating decimal. That makes it rational, so that is not true. C, the number, and we have our decimal, and it is not repeating, it is not terminating, so it is irrational. So C is 1. D, the number square root of 11 squared is rational. That is true because square root of 11 squared, that ends up equaling 11. E, number pi over 5 pi is rational. That is true because those will actually divide out and ends up giving us 1/5. So it is rational. So that is true. Number 10, classifying as rational or irrational. Okay. The first one is irrational. It is never repeating. It is non-terminating. So that goes on our irrational. 36 over 81, it is a fraction. So rational. 3 pi, irrational. Square root of 121 simplifies to 11. So it is rational. Square root of 7 is not a perfect square. So it's irrational. 0.3 repeating is rational. 0.123, it's a terminating decimal, so it's rational. And then our last one is irrational because it goes on forever, not repeating, so it is irrational. I'll finish up this review in part 2 of our Module 2 review.